Welcome to another warm-up. Take a few minutes, give these a shot. They're mainly review. All right, I gave myself a little bit of space there to work with. Let's go ahead and give these a shot. So I'm going to find the derivative. Notice this notation. Always try to use different notation every day. The derivative of 1 over x. So we don't have too many tools yet, so we're going to use that definition. H is going to 0. That is the change in x, or that's the run of our slope for our secant line. And then I need to figure out how to best write this change in the y values. So 1 over x, and then 1 over plugging in 1 over x plus h. So a nice composition of functions. Okay, our second y value minus our first y value. All right, that is pretty nasty. We'll see this again. This is really a test of your compound fractions. So what I'm going to do is bring this big nasty fraction up top into a single fraction. Here I go. I need a common denominator. That common denominator is x times x plus h. It's one thing times another. It looks like I'm going to get an x. I'm going to get an x times 1 minus a 1 times x plus h on top. This whole thing is just my numerator. So I'm going to put a nice big parentheses there all over h. Those parentheses matter. All right. And now you might need a little lesson. I'm sure I'll do this again in the lesson as well. But compound fractions, how do they work? A over b over c over d, parentheses, parentheses. If I'm dividing fractions, I'm really just multiplying by the reciprocal. So this is a over b times d over c. They flip on that second one. Multiplying is really nice because you are just going across the top and across the bottom. So notice what's happening here is that the denominators of each of these two fractions flip sides. The b goes to the bottom, that d goes to the top. So what's going to happen here is, still need my limit. This denominator is going to move to the bottom. So I get x minus x plus h all over h times that whole denominator is x times x plus h. Now all I got to do is simplify like crazy. It looks like on top those x's are going to cancel, and so I'm going to get a negative h, careful about that, over I get h times x squared plus xh. I intentionally just wanted to keep this h outside so that I could cancel those. Boop, boop. Almost there. This is a 1 up top now. It's continuous now, so I can plug in that 0, and it looks like I get a negative 1 over, careful, this xh here is going to 0 as that h goes to 0. So I just get a negative x squared. Cool. Now we know for sure that the derivative of 1 over x is 1 over x squared. And we can use that from here on out. All right. We'll also have other ways of doing that pretty quick here soon. Nice. That was probably our longest problem of the warm-up. A lot of writing there. You do get faster as you go. Let's draw the graph of a function that is continuous at x equals 3 but not differentiable at x equals 3. There are infinitely many ways to do this, but 1, 2, 3. Here's one. Just make sure it's got a corner there. So something that looks like an absolute value with a corner right there. I could actually draw this out. X minus 3 takes an absolute value and shifts it 3 to the right. That's probably the easiest one I could think of. Notice that this is continuous, so something that has, say, a jump or a hole would not count. All right, maybe the harder one. Let's try to graph just a quick sketch. really this fun function here. Notice that the slope is constant from -1 to 2, and that constant slope was a 1, so it's just going to go boop, 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 boop. It's not going to have a derivative at 2. It's going to go down to -1 because that slope is a constant -1 along that line until we get to 3. And then it looks like it is flat. Horizontal means no slope, not no slope, but a 0 slope. Okay. And now that slope is getting faster and faster and faster. It looks like it's peaking just above, actually just above 6 there. So really this is going up here. A max just above 6, and then it looks like it is back down to 0 by the time it gets to 7, and then it's more and more negative. All right, so it's a pretty bad sketch, but you see the main parts here, right? That where it's constant, we've got that. Where it's 0, we've got that, and then it's going to be positive. It's going to be positive all in this area here. It looks like it's going to hit a maximum right about here, and then it's 0 again right around there, and then back down and steeper and steeper and steeper, so more and more negative. In fact, I probably could, if I wanted to, imply that if this isn't asymptote, then it would have an asymptote here as well. So you might even do something very asymptote looking like this. Great. Practice those lots, and I'll see you in a minute.